Welcome to the fifth and the last lesson of the course on agent-based modeling in the MADAS master degree. Good morning to everyone, and as usual we start having a look to the result of the homeworks. Again, my compliments. A lot of name with 2 stars and at least 1 star and a 3-star case maybe applause today, the winner of the stars. Anyway, everyone will win a pizza. And if you want to have another food, it's no problem. It's possible to change the pizza. Someone does not like pizza, so any kind of food. We have to move in this way. We are here and we can follow via Bligny or via della Consolata. Via Bligny is shorter and Trattoria Caprese is here in the Savoia Square, but just 3 minutes. We can go together. The contents for today. Amy said to show you how to generate a web page from NetLogo. It can be useful to put online a model of yours linked to your page, a running model, without the need of installation by the user. There is a limitation. If the model is loading an extension, currently does not work online. But if we have no extensions, it works very well. Let's see an example. I open NetLogo. I load the model. Let me choose the historic segregation model, the first agent-based model created without the computer by Nobel Prize Schelling, game theorist. And in our library under social science, we have segregation. Okay. Now, from the menu File, I choose Save as NetLogo Web. And I save, in my case, on my desktop. From the open copy or from the library, as you wanted. We have not modified the file, so it is the same. And here we have the save the file. The extension is the typical extension of web files, HTML. I click on it, and in my browser, the preferred browser of Mac is Safari. If you have Edge, Firefox, Chrome, it's not important. And set up, go, it is running. The engine is the engine of the browser running JavaScript files. So it is translated in JavaScript and it works not absolutely always, but in a satisfying way. JavaScript is absolutely secure, so you cannot create damages to the computer or the other persons. Here you have the usual command center. You write online sentences in NetLogo and you have the reply. Here you have your code. You can also modify it on the fly and recompile. There is no automatic translation as when you have the local version, but anyway, you recompile. And finally, we have the infos, if you have compiled them, and the user can download both the HTML file, both the original NetLogo source. A very nice way for placing online our creations. I do that with the works made by my students of the econophysics class that they are preparing for the exam. And so it's a nice gift for them and their work online in my page. A lot of work now. Okay? It's just an information, but it is useful. Oh, stupid. Sorry. No problem. I leave it there. Second step, we again are in Python with network X. Yesterday we have browsed a lot of the examples, but we left a few of them. So I jump back to folder 4 for a few minutes. And what I want to show you is both the example mixed with network X and turtles, just to show that it is possible. It is not strictly necessary, but we can do that if we want. Here we have the class of the turtle imported from the library turtle, and A is an instance of turtle. As I run the code, I have also modifications of the position of the instances of turtle, so they are moving in their space. With run, now I am opening two windows. I hope. I hope. Nope. Okay. On the left, you have the window generated by network X. And on the right, you have the window generated by Turtle. Simply placing there the agent. We are doing nothing, but just to demonstrate that it works. If necessary, we can do that. As an example, your classroom is plotted here as a Turtle application, and there you are analyzing the network of the links among all the participants in the classroom. Nice. It is a bit heavy, but anyway, it works. Just as an addendum. Other example I want to add is this one. I run it via Jupyter. Hi, Julia. I show also the double star for you. So I want to announce that everyone today has made nice works. And let me use this as a Jupyter application. What do we add here? The position of the agents. Sorry, I added the name of the file. I have to stop to the name of the folder. The novelty is that I show you the file. In the Python file, I am managing a dictionary named position. This is a conventional name. is the default name of the position of the agent within the graph. And the position are set via a tuple. So round brackets as a vector, but we cannot modify it after having created it. Tuples are very quick in execution, they have a limit. But I suppose, I never tried, but I suppose that I can also place here a vector. It would work in the same way. Anyway, I have the position, the preferred position, and the run, in this case, after loading Pylab to plot, is producing this result, being in line, all the movement are reported. Here, in this case, it's very good to choose all output toggle scrolling to have a unique continuous window without scrolling, and we have the movement of the agents in the different steps. Or I can also have a unique picture if I flash the content of the picture before plotting again. In this case, it is stable. Stop. These are only information, uniquely information, to suggest to you a lot of possibilities when you use this kind of tools. Finished the part of yesterday, I move again to today. And I want to show you a link, a very useful link, this one. All the algorithms that you can use with Network X are listed at this address. Algorithms related to network analysis. And we have a lot of them. You see, plenty of them. Only the difficulty of the choice. And for each of them, there is the definition, the way of use it, and so on. Matteo Morini has created a new one named Bridge, the measure of the bridge between two communities. And if a few agents are connecting the two groups. Very interesting. In Network X, as an example, how do we run a calculation, an algorithm? Very simple. We have the graph, and so we apply the method or function to our graph. I wrongly closed the window, sorry. Lesson 5, Python again. I open simply with idle. Here I have only 3 agents, instances of A, and I calculate upon G the bitmatrix centrality, which is an algorithm included in net. Net is the local name of Network X. Betweenness is in Italian, I am not able to translate, but I imagine that immensità, the abstract version of in mezzo, is a good translation. Betweenness is the measure of the importance of a node in connecting the other one. As an example, if you and you are connected only by myself, you never communicate. There is a wall. My betweenness is 1. There is one path, the shorter path linking you passing by me. If we are all connected, the betweenness is 0 for everyone, directly connected is 0. It's a wonderful measure. It's one of my preferred. Let's run. I want to show how it is simple to do that. These are our simple node. Everyone is connected with everyone. So the result is that the betweenness is 0 for everyone. Sure. The measure is placed within the dictionary of the nodes. The reply is there. Let me create a larger network, this one. Now I have 500 agents, and sorry, I don't understand the if. I wrote it. Oops, I don't remember why. Anyway, run. A quite large structure with a lot of agents, and in this case, closing, we have the betweennesses. They are again all connected about every one of them. Oh, now I remember. Now I remember. This is the special case, but I can simply do this little change. In this way. Now, the result is a very complicated structure. Before I was linking only the diagonal positions, and in this case the network is very complicated, but our algorithm is anyway working, and in this case with different values because we have random connection, we are choosing randomly, and someone is not connected directly, so the number are not 0. Stop. This is only an example. Finished. Let me switch back now. I'm very tired today, so I close randomly immediately. I close randomly windows. I beg pardon because being distracted is not a nice way of being an extractor. Marco?
I was thinking that it seems to me that all these techniques that we explained yesterday and today, network description, analysis, etc.,
Yeah.
would be very could have a very good potential application in the sort of debate on financial crisis, too big to fail or too interconnected.
Sure, they do that. They do that.
Interconnected to fail. So, is there
Thanks for your observation.
literature on that, because that was it's still a very up to date kind of research field, and I'm not sure that many people, some people do, but not so many people use Python or NetLogo to run simulation and to write scientific papers on that field. How big should be or how interconnected should be an international financial institution to generate probability of general crash in everything?
Many thanks, Marco.
Next time after we finish the book, I would have an idea on how to do another paper on that.
Yeah, but there is a problem. There is a very large literature there.
In Python.
It's not relevant. Usually in Python, just because network X is very easy to be used. There is a huge literature there with authors coming from physics and computer science.
But the economists do not read too much.
But they understand nothing about the context where they evolve their networks. As an example, I don't quote the name, so I avoid as we are recording. If you want to know them after the lesson, I will tell you. Imagine to have a large network built upon a matrix. On the rows and the columns of the table, you have all the banks in Europe. You know about these banks' marginal values, all the credits and all the debits of your banks. But within the matrix, you know nothing. You try making assumptions. As an example, a large bank will have credit versus another large bank, and so on. Then you fill the matrix, paying attention that the totals are consistent with the marginal values you know. And then you analyze the content as a network. But you have invented it. You have discovered nothing. You have discovered the algorithm you used to fill the matrix. And this is in Physics A. So Physics A is a good journal. So if an economist want to enter this field, he has to fight against a lot of literature, wrong literature, but strongly diffused. It's a huge problem. Let me conclude. We can add a very important element to this kind of analysis. First, the economic knowledge of the problem. Second, no, three elements, sorry. Second, putting intelligence into the nodes. In the work I read about this field of research, nodes are absolutely doing nothing, are only a point in a matrix of data. If we create a dynamic version of this kind of model, nodes have to decide if we offer or not credit. How follow a strategy or another in recovery, and so on. The third element, this is done by computer science, sure, but it's very important, is to analyze this kind of networks upon time, in a dynamic way. Time is evolving, so time-temporal networks. Finally, but this is a huge work, years of work, we can create multi-layer networks, having each node as a pillar connecting different layers of interconnections. And this is adding a lot of information in a financial network. It is not easy. Anyway, the literature exists. Many thanks, Marco, for having me to pay attention to this important subject.
I have very quickly an idea on that field. So,
If you speak a little more loud for the microphone.
I have an idea on that field. The paper should reply to a question, so it should not be something completely outside of the work.
Yeah.
So, a very practical question could be: when should the central banker intervene? Because there's
Sure.
a problem of adverse selection. If the banks know that they will be safe at the end, they can be very,
Sure.
very risk-loving and put into danger the whole system. So
Absolutely.
when should a central banker intervene? And the point would be to construct
A
a
network.
network based on empirical data. So what is the share of portfolio investment of a big financial institutions in several other large international banks or large markets, financial markets, whatever? Construct and define in a software a measure of probability of default, which is a kind of defined on leverage measure or whatever, and then run a dynamic system to simulate that and see when a threshold of risk is transpassed. And so that could be a paper reply to the question: when should the central banker intervene, and when should the central banker just let the bank fail or whatever. Obviously, I cannot program all that, so it should be you and Matteo who do that.
Someone from the class?
Or someone else. I would be very happy, of course, to do that with someone of you. But I could write the equations, the mathematical model, and Since I'm not so good at
Okay.
simulation.
Very good. Applause. Let me go back now.
Sorry.
No. Just linking what you are proposing. Go back now to what I named a nice definition in the first day about agent-based models. It is important. I started from there. Now we have worked for 5 days. Let's go back and to read again the definition. And there you can also find the reply to your construction. And also the reply to what Gabriele was asking yesterday about assumptions. An agent-based computational model is a population. A population of what? In our case, the oligopolistic model, firms and workers. In your proposal now, Marco, banks, financial firms. What do we search? Regularities at the macro level. Our work now has been that of having a micro-founded model, but to observe the effects at the macro level, the business cycle, coming from the behavior of the agents, entry, exit phenomena. No equation governing the overall structure are stipulated in multi-agent computational modeling. So we don't define what the agent have to do. We observe what they are doing. Continuation. The equation are only present used the only equation are those used by individual agents for decision making. Yesterday, my wheel of action upon time was describing a set of decisions, not of assumptions. This is very different. The main assumption we refuse are perfect knowledge.
Maybe you should put the microphone.
No, the microphone is dead. This is a room microphone. This is not working. I forgot. The typical assumption we refuse are perfect knowledge of all the data, large computational capability, rational behavior. We refuse that. Our agents have nothing. They have local data, their data. A firm knows its production, sure, and the agent are making simple decisions in a micro way. My main master, Professor Ricossa, a lot of years, so I quote him, I'm very happy to do that. A lot of years ago, close to the beginning of the 80s, I show him my new proposal of researches, the starting point of my agent-based modeler career as the root there. And he told me, Pietro, you are doing now no more microeconomics, but microeconomics. Correct. Micro. Because if I look to the agents not as a black box, but as a sequence of actions, I am moving to the micro consideration of the economics first level to the micro consideration of it. And I wanted to introduce this consideration, and your example about banks is perfect, because in a paper like that we have to open the black box of the banks, and mainly of the central bank. How the central bank is deciding. It's not easy to be explained, but we can interview them. When I built my model about the delays in payment, we made interview to the treasurers of the banks to understand how they behave and how results emerge outside their decisions. This is very interesting. A lot of work for a paper like that. A lot of work.
After we finish the book, we'll do another paper.
Another book? No, another paper. Okay, stop. Now, advertising for Python. Yesterday, Professor Mazzoli, Marco, told us that Paul Romer, this year Nobel Prize, is using Python. And I told him that he had in an interview, he was explaining how he is using Python and what a kind of successes he had in teaching. Here you have Professor Romer, and let me go down. Instead of using Mathematica, with a lot of problem to share his work with the student and with other people, because Mathematica is costly and it's not so easy to run it, discover that he could use a Jupyter notebook for sharing his research, and so on, directly in Python. You can diffuse a notebook both as a file, but mainly as a web page, both static, because as you have created an IPython version in Jupyter, yesterday I shown you how to save as a Markdown or LaTeX, but you can also save as HTML, a web static page, or you can use tools like Binder, MyBinder, the free website you saw I use to run my SLAP online, to allow your readers to run your creation directly online. And if you have a server, you can, an open server, open to you, with the possibility of opening any kind of connection to this server, you can install your version of Binder. Binder is open source. You can install it when you want in your machine. So advertising with Professor Romer. Second interesting use in economics made by a Nobel Prize is that of the wonderful book wrote by Professor Sargent and Professor Stecharski. And it is a book of quantitative economics, this one, completely free, founded by the Sloan Foundation. And you have two entry points, the Python and the Julia. Julia is, I repeat, is an advanced language. Now we have the version 1. It is about 5 years old. And it is a super Python, as it contains directly very complex function. I don't know. The inversion of a matrix is made directly by an order within Julia. And as R, if you know R, you know that when you want to install a new feature, a new library, you order to R to do that. It's not your job. It's the job of R. And this is the same. It's a job of Julia to install a new part. And I make a guess. In 5 years from now, Julia will be very close to Python as diffusion. And Professor Stecharski and Professor Sargent has anticipated that. And have a look to the book. Here you have the contents of the book, a lot of economic, numerical calculations. MATLAB, to tell you, don't use it, please, and so on. It's a wonderful book, and it is very interesting that they are continuously improving it. It's not a static book. Being online, they add, they improve, they modify. Many thanks.
I'm surprised that Tom Sargent was...
Yeah, a surprise. The first time I jumped into this book, I guessed, but maybe is someone having the same name and surname. It's not him. I click on the link, it was the truth. Okay. Now let me introduce a abstract consideration upon networks. This is a set of ideas from Magda Fontana and myself. You know Magda Fontana. And maybe we will have the capability in the future to develop this kind of ideas. I start showing you a short presentation, then I will deepen one of the idea contained there. Anything is about networks and the use of networks to try to discover how people behave in a society. The presentation is this one, you have it online anyway. And you have also here the links to two versions of the paper. This one, the first presentation of the paper, you know, is a good idea when you have a paper to put immediately it online as gray literature. Gray is coming from the old cover they put on the first version of the papers. Now we have no more gray literature, it is online. And then you are sending it to the journal. But as you have it online in the first version, if someone is trying to copy your idea, you can explain that the idea was there and it was yours. This other version is on the Journal of Policy and Complex System, an interesting journal. I am advocating for it because I am one of the founders, publishing papers about any kind of research in complex system, but with links with policies. As an example, for Eleonora, if you are proposing a model about the income, the basic income, a first version can be placed there. This kind of journal are accepting that the author has then another more complicated and deep version to be sent to another journal. It's not considered a wrong way of behaving. Also on jazz you can publish the first version of a work, then improve it and send it to another journal. The presentation of the idea. We made it a few years ago, then Professor Marco attracted my mind to work upon the oligopolistic model,